origin, it drops to 37. So about 100 of those hosts were just for ads, trackers, and analytics. Right? So what I wanted to say was, what I wanted to see with OpenWPM is, what does that landscape look like? What techniques they're using, and so on. Right? So we can do things like say, who are the most popular trackers and where are they tracking? Right? And here you can see on the top million sites, Google Analytics, at least at the time of this measurement, which was back in 2016, was on almost 70% of sites. And so you could get an idea of what the landscape looks like, where things are loaded. We could say that, for example, news sites have the most trackers. And this is all kind of traditional tracking measurement. You can do this with a lot of tools, right? Just tracking with browser state. So if you're not very familiar with web tracking, the idea here is a resource from example.com might load on one page, which you're seeing on the top of the slide here. That resource sets a cookie. In that cookie, there's an identifier. And then when you visit example.com again in the future, your browser sends that same exact identifier back, right? And so example.com knows who you are. And example.com might not be loaded as a top-level page, right? This might be CNN and the New York Times. And now example.com's third-party content can track you with cookies across those two pages. So that's pretty well understood. But one of the things that we wanted to focus more on was fingerprinting. So fingerprinting is a slightly different way of tracking, right? Instead of kind of setting a cookie as we see in this previous example, instead, a tracker will send you a piece of JavaScript, right? And what that piece of JavaScript will do is do things like measure properties of your device to identify it. So do things like run through all the fonts that you have installed, right? Or look at your screen resolution, or look at your set of plugins, and so on and so forth. And what they can do is take all of those properties, right, put them up into a single array, and then push them back to their server. And they can do that on every page. So when you visit the New York Times, they could do it. When you visit CNN, they could do it. And they would build up this tracking profile, not using cookies, but just using the properties of your device. And these can get pretty complex. So what I'm showing here is canvas fingerprinting, which doesn't just kind of read a set of properties, but actually tries to tease out properties by drawing an image on the HTML canvas and then reading it back, hashing that image, and sending it back to the server. And actually, because of differences in rendering, it helps add to the identifying information about the device. But one problem is, if we want to actually detect that this stuff is happening, we have to do it by looking at scripts like this, right? So we can't just go and statically analyze, grep through the scripts and see if they're calling canvas or things like that, because a lot of these tracking scripts end up looking like the one I'm showing here on the page. So now I'm going to jump into the architecture of how we built OpenWPM. But I just wanted to mention, because I didn't at the beginning of the talk, if you have any questions, if anything's unclear, feel free to interrupt. I don't mind if anyone jumps in at any point. Not looking to just give a straight lecture. So given that we want to measure things like this, right, the more advanced tracking techniques, not just setting of cookies and so on, we wanted to build something that would crawl with a real browser. And the basic components of OpenWPM are built around Firefox. So we use Selenium. I'm sure many of you here are familiar with Selenium. We use it to drive Firefox. And then within Firefox, we have an extension. And so the extension goes and has probes on HTTP data. It has probes on JavaScript calls. I'll talk about that in more detail a little bit later. And then it interacts with the web. But if you've ever done automation with Selenium, you'll know it can be kind of slow. And if we want to reach 1 million sites, it's not really suited to just use it directly, right? We need to kind of build a framework around it. And so what we do is we wrap up that browser instance with Selenium and the extension into kind of something we call a single browser instance. And then we have a task manager that manages those instances. So we can spin up a new instance. We could have it visit us, tell it to visit a certain site, record a bunch of data, and then we could save all of that across a ton of instances to a single database and push that to some analysis scripts. And so the kinds of things that we save with this are HTTP data, JavaScript calls. We can save all the page content, all the cookies, flash cookies. So you can see kind of anything that might be interesting for a web privacy study, right? To measure the kind of things I showed at the beginning of the talk. And the overhead of doing these new measurements is pretty low, and that was one of our goals, right? We wanted maybe people who had questions that they wanted answered but couldn't actually go and write something like OpenWPM to be able to very easily spin up a new measurement. And so because we're using a real browser, we built in support for browser extensions like Ghostery and Disconnect and uBlock Origin. So if you want to go and say, okay, well, we know Google Analytics is on 70% of sites, but how many sites is it on when we're running Ghostery? You could just add in the Ghostery option and run a new crawl with Ghostery enabled and see how well it's working. We wanted to make it easy to add new commands, so we have a couple built-in commands, things like go get this website or a spider within the website. But if you wanted to say, go to a website and find a login box and fill it out as part of the crawl, then what you could do is write some simple Selenium code for that. And lastly, we wanted to make it easy to instrument new APIs to see what was going on. And so I'll go into that in more detail later. And so at a very high level, if you're looking to answer questions about what the web looks like, you should use OpenWPM if you want a real browser, if you need JavaScript execution, if you want the full kind of web API available, all the Canvas APIs, audio APIs, and so on, or if you need that deeper instrumentation that I'll talk a little bit more about. But you definitely shouldn't use OpenWPM if you want something that's very fast. If you only just want data from the top level page, right? If you only need to know about the initial TLS handshake, for example, or if you want to know just what the content looks like from the main page, not actually the rendered content, but just the HTML. This wouldn't be the right tool. It's way too heavy for that. And I've seen people trying to use it, and I'm saying, just use something simpler like requests or even just like headless Chrome or headless Firefox. So like I said, we have a bunch of built-in instrumentation to do these types of measurements. So I think there's three main areas. One is HTTP data, and we have all the typical stuff you'd expect. Things like the URLs that the browser is requesting for the top resource, all the sub-resources. With each of those, we know the top level URL it corresponds to, as well as the document URL. So we can tell if we see a request, was it loaded by the main page or was it loaded by an iframe within the main page, for example. We also have all the content. So we see the post bodies, we see the response bodies, we record them. And then we have the HTTP headers as well. So kind of the standard HTTP data you'd expect. But then we also have, because we're using an extension, we have a bit deeper access within the HTTP stack. So we can see, the channel flags that Firefox sets. We can see the JavaScript call stack. And that's super useful for these kinds of studies because let's say we see a request that is leaking your password to someplace. Well, we want to know what script actually caused that request to leak the password, right? And that's something we can do by looking into the call stack for that request. So OpenWPM records that data. We also have the DOM nodes, so we know if it's coming from an image tag or a script tag and so on. And we have like explicit redirects and also the security, the triggering principle and loading principle, which has some useful data. But the good thing is because of the way we're instrumenting it, we can save any kind of internal state that you could reach from an NSHTTP channel. Like I said, we also monitor JavaScript calls, and this is, again, useful for detecting fingerprinting scripts. So here, we can basically monitor method calls, property accesses for any built-in object that we're interested in. So we don't do it for all of them by default. The databases would be huge if we did that. But we do it for the ones that we think are most interesting, for whatever study we happen to be doing. And I'll show you actually a couple specific examples a little bit later in the talk. And so we know for every single call, right, the method that's being called, the property that's being accessed. We'll know the call stack at the time of the call. all the arguments being passed or the properties being set. Again, the document that it's occurring in, which is helpful. So is this call, is this canvas fingerprinting, the calls that look like they're canvas fingerprinting, are they happening within an iframe, or are they happening on the main page? And then, of course, we know the top-level pages that these correspond to. And lastly, we have cookie instrumentation. This is just, very simple monitoring of cookie sets, deletes, accesses. And you get all the kind of standard data you would for cookies, right? The creation time, expiration time, name and value, and so on. So just to give you an idea of how we do call monitoring, I'm showing an example of the canvas rendering context interface. And so that might have two properties, right? One is the fill text method, which will write text to the canvas, like I showed before. You might have all this overlapping text. And the other is a font property, right? That you can set the font for the canvas. And so in order to instrument this, what OpenWPM does is when the page first loads, we inject a content script into the page. And the content script actually goes and further injects something as a page script, so it doesn't have to deal with X-ray wrappers if you're familiar with the kind of security boundaries around extensions. And what we do is we run through any of the APIs we're interested in. I'll show you how we define those in a bit. And what we do is we overwrite the getters and setters for all of the properties that we want to log. So for canvas, we can overwrite the getter and setter for fill text and the getter and setter for font. And the great thing is that when a page script goes and accesses fill text or accesses font, we can go and actually determine the call stack at that time. We can see the arguments. So that's how we're able to record all of this data. And it's totally generic. So if we could do it for canvas random context, we could do it for the audio context, or simple things like document.domain, right? So you could see how any interface is being used. And the good thing is we've structured it such that instrumenting these APIs is a relatively low cost, relatively low effort. So the instrumentation necessary for detecting canvas fingerprinting is something like less than 10 lines, as I show here. We just need to actually check the HTML canvas element and the canvas rendering context prototype elements. And so any instances of those that are created during the page visit will actually see all the calls to them. Same thing for audio API down here. We instrument the prototypes of a bunch of the various nodes that might be used within the audio API and the actual context for the audio API. So again, it's just a few lines of code, and we could go detect a new fingerprinting technique. And the crawl scripts are fairly simple as well. So here it's 34 lines, and this crawl basically grabs, uses some helper functions to grab the top 1 million sites from Alexa, turns on the cookie instrumentation, the JavaScript instrumentation, the HTTP instrumentation, and then basically sets the output to S3. So we support writing into a local SQLite database if you're doing a pretty small crawl, or if you're going to be doing a very large crawl, we can output that to S3 to make it easier to work with. And then we just spin up the task manager and for each of the sites execute a series of commands. In this case, I'm just showing what it would be like to visit the site, right? Execute a get command. So let's look at a quick example. Canvas fingerprinting. So as I mentioned before, the basic idea is a fingerprinting script will load on the page. They'll write some text and some shapes to the canvas. They'll read it back as a data URL, and then they'll hash that, right? And when kind of showing you on the left side of the slide here, an example of that, but on the right side is a more complex canvas fingerprinting canvas that we found in the wild a couple of years ago. And so as I mentioned before, we'll have that instrument object measurement code that looks at the two prototypes that we're interested in. And then when the actual canvas fingerprinting JavaScript loads on the page, we'll see in our call logs something that looks like this, right? The call stack, the methods being called, the arguments being passed to them. And then what we can do is go and examine that API use, check for tampering and so on. And actually, the canvas can be used in a couple ways to fingerprint. A second one, if you're not familiar with it, is using it to actually pull out fonts that are on the machine. So without Flash, there's no way for a script that's loading on the page to determine directly which fonts are installed, right? You can't just ask the browser, give me all the fonts that are installed. But you can infer it. And the way you can infer it is by telling the browser to draw text in a certain font to a certain element, and then measuring if that text is equal to the default font. The idea being, if you're drawing text and it's equal to the default font, if you're drawing text in some other font, let's say it's Fantasy, as they have on the side here. So if you request the browser to draw in the Fantasy font, and it ends up looking like the Arial font, well, then you know that Fantasy font isn't installed because it fell back to the width of the Arial font. But if the width is different, right, than the default font, then you know that the Fantasy text is installed. And so that's kind of the example here, right? If Arial is the default font, if you go and request an element to be drawn in Times New Roman and it's at 33 pixels instead of 44 pixels, well, then you know that Times New Roman is installed. And what you can do is run through a ton of known font names and check if they're installed. And so actually, I'd like to show a demo looking into some of our data on how we would detect that. So I got to switch video over to that screen. So any questions so far? Is anything unclear? Feel free to jump in. Okay, nice. Is this visible or is that text too small? Probably too small.
It's a little small, yeah.
Okay. Is that better?
Yep, that's better for me.
Perfect. Okay. So there's a bunch of stuff here that you don't really need to worry about, but let me give you some background. So what I did was I set up a crawl to run on the top 20,000 sites, and I set it to save to S3. So we visited each of those sites. We had HTTP data recorded. We had JavaScript data recorded. And then I said, okay, write all that to S3 at this bucket, OpenWPM crawls with this name. So all I'm doing here is creating an S3 URI and loading it in using a Parquet loader. So nothing too much to worry about. Then I just add some extra columns that might be interesting. But here's what I wanted to show. So now that we have all of this data loaded in, and we have all the HTTP requests for the 20,000 sites that we visited. Let's say I want to answer a question of how many sites is DoubleClick loaded on. It's super easy to do. Right? You can just say, give me all the requests that have a public suffix +1 of DoubleClick. Tell me how many unique top-level URLs it's loaded on. Right? And then we can see it's something like 63%. Right? Maybe we want to see how many URLs Google Analytics is loaded on. We can see it's 70%. And maybe we want to check Facebook, right? So we could simply check how often Facebook is loaded, 40% of the top sites. And so these are simple answers, simple questions to answer, but we can do more than that, right, with the data. And like I said, because we have the call stack, we could answer kind of more complex questions, right? Which is, how many domains does DoubleClick load? So actual DoubleClick triggering the load of other resources from other places. And we can do that by saying, okay, for the requests table, we can check, where the call stacks aren't empty. We'll end up with call stacks that look like this. But if we parse out all the domains from that, right, we can end up instead with something that looks more like this, right? So now we can see for every request, which domains were involved in triggering that request if it was triggered from JavaScript. And so that lets us do something like check all of the requests for which there was a triggering domain in the call stack that was DoubleClick, right? And then we could see by grouping them by the number of sites they could appear on, you can see that DoubleClick is embedding resources from Google syndication on 37,000 sites, right? Or DoubleClick is embedding resources from Double Verify on 1,000 sites. And that's interesting because Double Verify from past research we know is a fingerprinting script. So here we could see on which sites is DoubleClick pulling in a fingerprinting script, right? So we could see that DoubleClick is responsible for causing fingerprinting to happen on some number of sites. And I just wanted to go through that to give you an example of, in just a few lines of code, how you can understand some pretty cool things about the web. And now I want to move on to a fingerprinting example. So here we have all that JavaScript data that I mentioned. Again, we're loading it in from S3, doing some simple analysis just to add some extra columns that make it easier for us. And then what we can do is very quickly check where fingerprinting is happening. Right? So maybe the first thing we decide to do as part of that is say, give me all the sites for Canvas calls, where Canvas calls are happening. Right? And this will take a second. And so we see here, okay, well, these are all the places where a Canvas call is happening. And we could see which methods are being called, on which scripts are responsible for calling those methods, and also on which pages those are happening. Right, so this is everything we need to detect, is someone actually trying to fingerprint the user. Maybe they're using it for benign purposes, maybe not. So the Canvas font fingerprinting example that I showed is really kind of an excellent, very simple example to show how easy it is to detect when it is fingerprinting versus when it isn't. And so if someone wants to fingerprint with fingerprint fonts with Canvas, one of the things they need to do is measure the text, right? They need to draw some text to the canvas and measure it. So if we expect someone to be rolling through text measurements, or if we see someone rolling through a bunch of measured text calls on a bunch of different pages, we know that they might be a fingerprinting script. So let's do that. And so what I'm doing here is, again, showing all of the scripts that are calling Canvas rendering context measure text, and I'm just grouping it by the sites that they're calling it on. So we see that math tag, which is a tracking script, is making calls to measure text on 55,000 times, right? That's not necessarily 55,000 pages, but they're making calls 55,000 times. That's kind of a suspicious number of calls. So what I can do is, because we actually have the arguments that they're passing to it, I could say, well, is math tag passing, maybe they're writing different text on every page, or maybe they're writing the same text. That's important, because are they doing that kind of measuring the width of the same exact text, or are they measuring the width of different text? And by running through all of the things that they're passing, or, all the arguments that they're passing to these calls, we see that they're actually only calling 55,000 times. They're calling measure text on the same exact string across all the pages that they're loaded on. So that's a bit suspicious, right? That might mean that they're doing something with this that you probably wouldn't really have a reason to do unless it was fingerprinting. And so then we could just do another check, say, well, if they're going to be fingerprinting fonts, they actually need to draw a bunch of different fonts to the canvas, right? They can't just fingerprint the same font. Maybe they're measuring the same length of text, the same text, but they actually need to measure it with different fonts. So let's check that. And this is a pretty good indication that they might be doing font fingerprinting. So what we're seeing here is, by checking all of the calls to the font method, or to the font property of Canvas, when it's coming from math tag, we can see that they're setting monospace on serif, so on and so on and so on, right here for what has to be probably 500 different fonts. So that's a very suspicious example, right? And maybe we check another one with add micro, for example. Or actually, let's use the second one, this add bet. So here we see something a little bit different, right? Here we're seeing calls that appear to be drawing or measuring the text for dates, for locations. So maybe that's something that isn't actually trying to font fingerprint, but uh, trying to do something that is actually useful for the site, right? And so if I check the fonts that they're calling it with, we can see they're doing across all pages, right? They're only calling the canvas with 2 different fonts. So it's very unlikely that they're using this for canvas fingerprinting. And obviously there's a little bit more to that to make sure that my intuitions are correct, but I just wanted to give you a very high level idea of how easy it is to see what scripts are doing once we have the kind of instrumentation in place that OpenWPM provides. And so now I'll switch back to the presentation. Okay. And so just to comment, to finish, some future directions. It's definitely true that OpenWPM needs some love. Like I mentioned, this was largely a graduate research project before coming to Mozilla. So the instrumentation right now is still built on the add-on SDK extension framework, and thus built on Firefox 52 ESR, which was just end of life at the beginning of the month. So right now, if we run crawls, we can only run them with an end of life browser, and we can't actually check any new APIs that are present in new versions of Firefox. And so we have some efforts there to update the instrumentation to a web extension where possible, or to a web extension experiment where we still need the kind of deeper instrumentation or deeper channel access that I mentioned earlier in the talk. And we also have a bunch of this kind of data leak and pioneer study repos that I'm linking to here, do somewhat similar things, and they've pulled some code from OpenWPM. And so we want to make it possible to share the same instrumentation across the crawling code that I have in OpenWPM, and maybe like a pioneer shield study that would ship to real users to detect these same kind of things that I just showed you. And so we're trying to isolate out the instrumentation code and bundle it up in a way that's very easy to reuse across extensions. As I mentioned, it's super slow. It takes about 30 seconds per page visit. So even if you're running with 15 instances in parallel, crawling 1 million sites takes about 15 plus days on a single machine. And so we're going to be setting this up to run on multiple VMs in a cluster. And the data sets can be really unwieldy. So prior to this week, we actually didn't have support for writing directly to S3. It only used to write to SQLite. And so that meant if I wanted to share a data set, 1 million site data set with someone, I needed to share, a 300 gigabyte SQLite file that was completely impossible to work with. And so instead, we're now writing directly to S3. So we can do the kinds of things I just showed you in the notebook, where you could simply pull it in as a Parquet data set from S3. And so thanks for taking the time to listen. I have a bunch of different repos you might be interested in if you want to see more of both the crawler and also the analysis stuff that I just showed you. The notebook that I walked through is available on this OpenWPM crawler repo if you want to go and play with it yourself. I think you'll need to get requests. You'll need to ask me for permission to access that S3 bucket. But aside from that, you should be able to play around with it. Thanks. Happy to take any questions.
Thanks, Stephen. Yeah, that's great. I've got a few questions. I'll kick off with those, but I'll also pause in between in case anybody else would like to go ahead. First off, I'm interested, you're using Selenium. Does that mean that this framework works in other browsers, or is it only Firefox?
So that was the original goal, was for it to work in other browsers. Unfortunately, because we started out with it running with a proxy, and with a proxy you don't get all of this kind of deeper instrumentation, right? You'll only see request responses flying across the network. So then once we switched over to using an extension, we kind of dropped any hope of supporting Chrome. But now that Firefox's extension framework is web extensions, I think it might actually be hopeful that we could support other browsers again. Um, it's not an immediate goal because I'm more interested in what the scripts are doing than how they're responding to Firefox. But it is a long-term goal to get it to support Chrome and maybe other browsers in the future.
So I guess a lot of these trackers are really exploiting gaps, privacy gaps in browsers. And like you say, some of these are, or some of these methods can be used in a benign way to actually improve the user experience of a website, whereas they could be used also maliciously or depending on your views of whether or not tracking is a good thing. What can we do? What can Firefox? What can we do to improve stop the trackers with the users that don't want to be tracked, without impeding the proper use of these APIs? Is there ideas on how we can improve Firefox to protect our users?
Yeah, definitely. So this is actually kind of my main focus in my job here at Mozilla is trying to protect against these things. With fingerprinting, we're in a tough position. I think there are two avenues that you could go. One of which is to use the Tor browser style of fingerprinting protection. So if you're not familiar with Tor browser, it's essentially a privacy-focused browser that communicates over the Tor network, so it provides network anonymization. But if a site could still fingerprint, then you kind of break all of the reason to have that network anonymization. So at the same time, they want to protect against fingerprinting. And the way that they do so is by changing the way these APIs operate. So for the Canvas API, what I think they do is they show on the initial call to Canvas, they'll show a blank screen. They'll return a blank canvas. So you can't fingerprint blank canvas because there's nothing rendered to it. And they'll ask the user, would you like to allow this site to use Canvas? The user could say yes or no. And if they say yes, then future calls to the Canvas will work and will render correctly. But the site would be able to fingerprint. So sometimes they ask the user, and then other times they might disable an API. So like the audio context is disabled entirely because it's not really used that much by sites. And then other times, like what they're trying to move to at this point is, well, that idea of asking users about Canvas is kind of terrible, right? So maybe we can make the Canvas unfingerprintable. So they're restricting the set of fonts that can be drawn to it, doing software-only rendering for it, exploring whether that totally fixes the problem right now. But the problem there is now if we've designed Canvas to be efficient, and software rendering slows it down for a bunch of users, do we really want to deploy that to every user, to every Firefox user? Right? We're kind of changing we're shipping non-standard operation by default. So I think the other option is detecting these Canvas fingerprinting scripts or detecting any fingerprinting script in the ways that I've shown you in that demo, and then doing something about it. Your options could include blocking that script, applying some restrictions. Maybe you apply the Tor patches to that page only, where we see the fingerprint happening. Right? So trying to use measurement to be a little more intelligent about when you apply restrictions. And what we'll end up doing, where we'll end up or other browsers will end up is yet to be seen.
So I'm curious to know how we are discovering new ways in which tracking is being used, or some of these APIs are being potentially misused for tracking purposes. I remember the speaker series where I think it was Arvind was talking about using the battery level API to essentially reveal someone's private browsing session, because certain things would be identical in terms of the battery API and other aspects, which it's kind of mind-blowing that these things that have been put in there for purely um, uh, good purposes, good use cases, and yet they're being misused for tracking. How are we confident that we know all of the ways in which people are tracking us or tracking our users? How are we discovering new ways in which these techniques are being discovered?
Yeah, so that's a good question. Um, I think there are a couple approaches, but the simplest one is, let's say I flagged that math tag script as maybe that's fingerprinting. Right? Let's say we verify that it is doing font-based fingerprinting. What we can do is we can instrument other APIs. Like if we suspect that the battery API is also being used with fingerprinting, we can instrument that and see, is that same script calling the battery API and how are they using it? Or maybe we add some new API, like media capabilities. And we could say, is anyone using that in a way we don't expect? Right. So it's kind of branching off of known fingerprinting scripts to detect other techniques that they start using. And that's actually how we discovered the audio API being abused. So we were looking at scripts using Canvas and WebRTC, which were known to reveal identifying information. We said, hey, one of these is accessing the audio API as well. What are they doing with it? And then we did a measurement of it across the top sites. And one of the things that I think has been super beneficial for us is the relatively low usage of some of these, right? Like the audio API was not being used very frequently. And actually, if a tracker picked it up and they were on 10,000 sites, then we see this huge jump in usage. So I think it's actually that tracking scripts tend to be early adopters of these new APIs. And what you could do is when you first ship an API, do some monitoring and see if someone picks it up and how they start using it.
That's really interesting. I kind of have this vision of there being some kind of underground communities, maybe on the dark web, where they're discussing these techniques. Because otherwise, I don't see how these various different companies sort of come up with the same techniques. It's fascinating.
So I will say there's Fingerprint.js, Fingerprint.js2 or Fingerprint2.js is an open source library that has a lot of users. We see a lot of instances of it around the web. So there is a kind of a standardization around fingerprinting that's happened over the past 5 or 6 years. And they have a big list of like, we would love to fingerprint with these techniques, but we haven't implemented them yet. So there's a known possible future direction that someone may make a pull request for, and now it ends up on a bunch of sites.
These tracking techniques obviously must have some level of performance impact on site loading. Is that just a side effect of OpenWPM in that we may be able to understand the impact there, or is that another goal here?
So I don't think we have the right instrumentation right now to know performance impacts. We could add it, and if we were interested in detecting, if someone were, for example, like mining cryptocurrency, we could add instrumentation for that. I don't know exactly what it would look like, but you could say, look at resource usage and see if there are common scripts between high resource usage websites or something like that. I'm not actually sure what the general performance impact is of these fingerprinting scripts. I've never measured it. I suspect it's pretty low. I think it would only be, I think maybe some of the more complex Canvas or there's actually WebGL fingerprinting as well, where you have to do a bunch of rendering, would be the most likely candidate to cause performance problems.
So are you currently running these on a regular basis, or I know you mentioned that it's on a unsupported version of Firefox at this point, so maybe that answers that question. If it does, what's the goal going forwards? How frequently will you run these? Are you intending on having a dashboard that shows um, improvements over time, that sort of thing?
Yeah, so during my PhD, which ended June this year, we were running the crawls regularly. So once a month for all of 2016 and 2017. We do plan to release that data. I should have put a link in that last slide for the release. I think we're getting pretty close, but it's been a low priority, so I'm not sure when that will get posted. Uh, but that's just a bunch of data sets. There's no dashboard. There's nothing like that. Here at Mozilla, what I'm planning to do is get crawls back up and running. To do them regularly. I'm not sure yet to exactly how regular that will be. At this point, I'm kind of running things one-off on my own. If I'm interested in looking at canvas font fingerprinting, I might run a crawl, like I just showed you, do an analysis myself, uh, and do something with that. But eventually, I would like to open it up that other people could say, oh, here's the S3 bucket with all the crawls. If we want to spin something up, here's how I can do it. I could have other people at Mozilla dig through the data the same way that I showed you. And eventually, maybe down the road, we have a dashboard, but that's kind of not part of the immediate goals.
Last question from me, at least. Is there any um, sort of desires, wish list features that you have for Selenium or the stack there? Because of course we have Selenium Marionette is the server inside of Firefox and Gecko driver. So, is there anything that you wish that toolset had that would make OpenWPM easier, faster?
Yeah, that's a good question. It's a good question. I know that there are things that I do wish it had, but I don't know. I don't remember them off the top of my head. It's like I encountered this during development and probably filed a bug about it, but never. Yeah, I'm not sure off the top of my head, but I know there are things. Do you know who maybe people on the call would be the right people to ask? I'm not sure. I know.
Just looking at the participants, it's possible. I know that Henrik is heavily involved in Gecko Driver and Marionette at this time. That's Wimbu in the Automation or 18 channels. Um, but yeah, it just we do have people who are working on these areas. At the moment, it's a case of getting it to spec compliant. So anything else would probably be not prioritized. But it'd be really interesting if there was something that would make your life a lot easier that maybe we could help to at least guide you in, or maybe even have some cooperation, some community collaboration, some sort of mentored bug or something like that.
Yeah, yeah, yeah. That would be awesome. I know that in the past we've run into problems where we were like, oh, if only this were different. Um, I know one of the kind of long-term design goals that isn't related to Gecko driver or Selenium, but is moving some of that JavaScript instrumentation into the browser, into Firefox. So it's a pretty messy way of doing it right now, where we inject, a content script which injects a page script which is detectable and editable by everything else on the page. It'd be nice if we could do that within the browser itself. So that's kind of a long-term thing we may end up changing to support this effort.
Mm-hmm. Yeah, that sounds interesting. Like, there could even be something that could be so we have the sort of vendor prefixed commands in Gecko driver, so that are outside of the Selenium driver spec, and so it's possible we could have something that is specific to measuring for OpenWPM. That if you're using Firefox, it will do the right thing.
Cool. Yeah, that'd be awesome.
Okay, I'll stop there. That's all of my questions. But if anybody else has any questions, please go ahead.
Yeah, I had a random one. Is that a Super Nintendo back there?
Yes, right here.
Yes.
It is. It is. It's actually a replication made by a company called Analog. So it will run real Super Nintendo games, as you could see down here, and output HDMI, so you could connect it to a TV.
Oh, sweet.
I could drop the link in
Just the QA just
in the Slack channel.
Please, I would be interested in that.
Yeah, we'll do it.
Thank you.
Okay, so if there are no more questions, we can wrap there. Like I said at the beginning, look out for an invitation for next month's with Peter from Wikimedia. But other than that, just like to say thank you again to Stephen for being our guest this month. And take care, everybody. Thank you for coming, and see you all again soon.
Yeah, thanks for having me.
Cheers.
Thank you.